Hey guys, welcome back to Session 8 of Introduction to Linux System Administration. This is going to be our last session for this course. As always, I am your instructor, Kevin Downs. Today, we're going to be finishing up with controlling processes. So last session, we went over file permissions, directory permissions, octal representation, changing permissions, setting default permissions, access control lists, the get FACL and set FACL commands, and the set user ID bit, as well as the group ID bit and the sticky bit. Today, we're going to be going over characteristics of processes, parent-child relationship, examining running processes, background processes, controlling processes, signaling processes, killing processes, automating processes, cron and cron tab, add and bash commands, and system processes. So guys, basically we're going to be looking and discovering all about processes and how to control them, okay? So let's go ahead and look at characteristics of processes. So processes carry out tasks within the operating system, and a program is a set of machine code instructions and data stored in an executable image on disk, and is, as such, a passive entity. A process can be thought of as a computer program in action, okay? It is a dynamic entity. Constantly changing the machine code instructions are executed by the processor. In addition to the program's instructions and data, the processes also include the program counter and all the CPU's registers, as well as the process stacks containing temporary data, such as routine parameters, return addresses, and saved variables. So the current executing program or process includes all the current activity in the microprocessor. Linux is a multi-processing operating system, and processes are separate tasks, each with their own rights and responsibilities. As such, if one process crashes, it will not cause another process in the system to crash. Each individual process runs in its own virtual address space and is not capable of interacting with another process except through secure, kernel-managed mechanisms. So let's look at the parent-child. Let's look at the parent-child relationship. Every process has a parent process, meaning that when a process is created, something created that process, and it may or may not have child processes. Let's take this one by one. Consider the output of PS command. Now, so when a process creates another process, the former is called the parent, while the latter is called the child process. Technically, a child process is created by calling fork function from within the code. Usually, when you run a command from the shell, the fork is followed by exact series of functions. Okay. So, guys, what this fork thing means is that we create a process, and then more processes can be created off of that and create like a fork. Okay. And then you can see how that would keep forking off of one another, etc., etc. And each time a process is created, that's known as the child process, and the process that created it is the parent process. This is important to know because if you have a process that's running wild and you need to stop it, stopping the process might not be the actual solution. You may need to find the parent process of that process and stop that one to truly stop what's going on. So to examine running processes, the Linux terminal has a number of useful commands that can display running processes, kill them, and change their priority level. Here we list the classic traditional commands as well as some more useful modern ones that we'll discuss. We have top, htop, ps, pstree, kill, pgrup, and pkill, which is process kill. We've looked at a few of these such as top, ps, and kill, but we can go ahead and pull these up again just to show you them. Let me log in here. Oops. Come on. There we go. Clear my screen here. Let's do a top. So remember, top is a live view of what's going on in our system. All the different processes, the CPU usage, and memory usage. To get out of top, we hit Q or quit. Remember, top will stay there, though, even when we hit quit, so we'll clear our screen to get some more space. We can do PS to list the running processes. In this case, all we have is bash, which is our shell running, and then PS, which is the PS command we just ran. Okay, and then we could type in kill to run to kill a certain process, but we'll look at that a little bit later. Let's go ahead and head back to our PowerPoint here. So next we're going to look at background processes and how those